Let's start with the basic building block. The dot product of two vectors, u and v, is written u dot v, and it equals u sub 1 times v sub 1, plus u sub 2 times v sub 2, and so on, all the way through to u sub n times v sub n. The length of a vector v, written as magnitude of v, is defined as the square root of v dotted with itself. Two vectors are called orthogonal when their dot product equals 0. This is a purely algebraic fact. It just means the numbers work out to 0, no picture or diagram is required. Let's work through a full example. Take two vectors in three-dimensional space. V sub 1 equals the vector 1, 1, 0, and v sub 2 equals the vector 1, minus 1, 0. To check whether they're orthogonal, we compute v sub 1 dot v sub 2, that's 1 times 1 plus 1 times minus 1 plus 0 times 0. Adding those up, we get 1 minus 1 plus 0, which equals 0. Since the dot product is exactly 0, v sub 1 and v sub 2 are orthogonal. Now let's find the length of each vector. The magnitude of v sub 1 is the square root of v sub 1 dot v sub 1, which is the square root of 1 squared plus 1 squared plus 0 squared, giving the square root of 2. By the same method, the magnitude of v sub 2 is also the square root of 2, since squaring removes the minus sign on the middle component. Next, we normalise each vector, that means dividing it by its own length, to shrink or stretch it down to exactly length 1, without changing the direction it points in. Dividing v sub 1 by the square root of 2 gives us u sub 1 equal to the vector 1 divided by the square root of 2, 1 divided by the square root of 2, 0. And dividing v sub 2 by the square root of 2 gives us u sub 2 equal to the vector 1 divided by the square root of 2 minus 1 divided by the square root of 2, 0. Now both vectors are orthogonal and both have length exactly 1. Together, u sub 1 and u sub 2 form what is called an orthonormal set, the cleanest possible building block for everything that comes next: projections, Gram-Schmidt, and least squares. Like and follow for more math tutorials, one idea at a time, nothing rushed.